should pop up any moment now. There we are. Okay, cool. Well, hello, Jay.
Hey, Llewellyn.
So we have a couple different things planned for today, but let's start by continuing off where we were 2 weeks ago. And it looks like past us was nice and left a little to-do method.
Always some to-dos.
Well, there's one right there on 58.
Yeah. Okay.
Fix this. Start here. Refactor this function into a link state. Oh, right. Yeah, these little notes are super helpful. So if you remember last time, we did this and it didn't work,
Mm-hmm.
right? And I think part of the reason is because of the mask and the link. So let's take that is any digit possible on 262, and let's just inline that right away.
This the method.
Yep.
Only one reference, so you may as well take them all.
Yep. And then
And silly resharper has given
we
us
can sort of
variable we don't
inline
need.
that is any digit possible part.
You want more inlining than that?
Yeah, inline it even more, I guess.
Okay.
Okay. I think the get mask for digits.
It's used here
I don't
and
want to
here
inline
only.
that. Get candidates masks. Can you inline get candidates?
So
Don't get rid of this.
Yeah, I'm just checking it has 5 references. If it was only one, then I just be different. Oh, nice. If false.
If false. So that means we don't do that. So we can get rid of that. No. Oh wait, false or. Okay,
I
yeah.
don't know. I just did what resharper says.
I'm glad Resharper is thinking because I was not. Okay.
All right, where does this variable come from?
Which
Oh,
one?
this is a field. This is
It's a
candidates.
field, yeah.
Do we need this check? Oops, that's not how you do
Yeah,
it.
I think so, but we can find out.
Is it? I think it's hung.
It's hung. Yeah, so we do.
Yeah. Okay. Cool. All right. That makes sense. I'm
Okay.
okay with that.
Um, and then so what is candidates itself?
It is candidates.
Which is just a
It's a,
container for masks. Okay, so let's see if we can do the link on the masks more directly. So let's take the masks.
is this the only place that deals with this field?
No, definitely
okay.
not.
All right. Sorry,
So
go ahead. What were you going to have me do?
let's take the masks and start by just linkifying this thing, right? So we get the location of the cell index, and then we take the thing. So let's see if we can get that out first, and then so take a line 268 and extract the indexed. No, just the index that we want. Yeah.
We want this much.
Yep. Yep. And then move it up.
Okay.
Because you should be able to move that. Oh, I guess we need to move masks down for right now. Not that far down. Yeah. And let's move the cell index up even one more line.
You want me to inline this?
Yeah, actually, that's fine.
I don't really have a sense of where you're going. So
I'm trying to start to linkify this statement. So I think what we can do now is do where we say candidates.mask, we can do .where, and then we want to check that the index is equal to the index. Is there a where that takes an index?
I know there's a
Yeah.
select that does.
So there's a where it takes two ints. And int. But which int is which?
It's a secret. We want I or I1. I don't know. Yeah.
Control click on where. It's decompiling. Great.
The second parameter is the index.
Yeah. So let's rename these slightly differently to index is this or the second one.
We already have a lot of things called index, but okay.
Mask and yeah. And then we want to say where index equals location dot to index. Yeah.
This is going to become.
And then you can get rid of that and that. And why is it complaining about mask?
There we go. Oh, M.
Just call it
Oh,
M.
I've been using it.
I understand even better.
Best name.
Nope. Okay, so now the question is, why is this not the same thing? You think there's an off by one error on the index?
I don't know. Let's see what kind of failure was it. Timeout. Let's start over.
Yep, I'm good with that.
Because there's at least one step that we could do. We should inline this variable.
Sure.
Because we're trying to convert this
And
statement.
then there's slightly, click on masks and see if there's a quick fix to make that a link statement. No. So our where is not working the way I think it does.
So try it again. Thank you, intelligence. I feel like this is what we wrote before.
Yeah. So this is going to fail.
I think you're right.
But what I want...
But I also felt like the change was totally legit. So.
Yeah, so we're going to try two weird things. Here where it says the I, put an I plus 1. And do an I minus 1.
That's cheaper than thinking.
I mean, it's just checking. Try this. Do a... Can we just go to a test for a second? Or even a command line REPL would be great for what I'm about to do.
For C#? Or I don't know where to find a command line REPL.
It's fine. Just go to test. Test will do good. I don't think our indexing is working the way that we think it does. So make an array 1, 2, 3, or ABC, or yeah, you can do a range. It doesn't matter what the range is. In fact, let's purposely not do 1, 2, 3. Oh no, 1, 2, 3 is great. 1, 2, 3, and then on this do a dot select and 2 integers. And return y, because y is what we think the index is. And then just verify all that, or print it out, or something. You have to run it manually to see the error. So I'm
What button
expecting
is
this to
that?
say 0, 1, 2.
Yeah, you're right.
Huh?
I didn't have nearly as much content as I expected it to.
4?
What's up with that?
What?
I don't get why is it empty. Okay. Verify all.
Put a label in here that's more useful. And go back to the thing. Oh, scroll up. I think there's a
Aha. There it is. It's
0, 1,
unfortunate.
2.
Oh,
Okay, so that is
weird.
what I expect.
Okay.
So then let's go back and do the next test. And say, instead of select, say where. And then say y equals 1. And what I expect from this is 2. This is not going to be an array. Oh, no, it will be an array. So it'll work. Wait, what? Scroll up. 2. Okay. Unfortunately, this just leaves me more confused than I started. But it means all of the things we were assuming were correct. So now let's go get yeah. So this is going to give us B when we
Yeah.
select for
Char
where.
and int. Yeah. We were right about that.
Yeah. All right. So remove that test and let's go back and see if we can understand why our conversion doesn't work.
Why isn't this
Refreshing properly?
0, 1, and 2? Did
No,
I do
this isn't the
something wrong?
latest output.
Oh,
Yeah.
okay.
You just have old ones. So delete this test. Let's go back and look at what we did in the code. Because now all my assumptions are sort of matching. And what I'm going to do is I'm going to try using the technique that we used. Because that's I.
No, no, I was just playing with it. We were using I before.
So what we were doing, okay, so revert this for a second. We're going to redo it, but. So let's use the technique we used before, which here we're going to say var c2 equals candidates mask. Now you need to do it underneath. And then,
So,
yep, so assert that these two things are the same.
I know we can do element at. I'm not saying that this is better or even closer, but
No, but I like this.
it's
So let's try
linkier.
it. Good. And now let's change that element at to a where.
I wish I could
Yeah.
linkify that. Maybe the fact that it won't linkify is because they know what we're trying to figure out.
Maybe. I equals location.
Oh, so sorry. I tried to mute.
Huh. That's weird. Okay, no, that makes sense. Okay. And how did this fail?
Timeout.
You think the where is problematic?
That's strange.
Because I would have assumed it was the debug. Instead of, do you understand what's happening here?
Not really, but I do notice this is a yellow dot, which means that it's slower.
Why is it slow though? All right, well, let's do element at then.
We debugger it?
Let's just do element at.
Okay.
I don't understand what's going on here, but we'll just accept our limitations. And then, can you do a select on an element at? You can't, right? So we have to do
It's
our
just the
select
element.
first. Oh, try this. Try just a. Oh no. Oh no. You have to do a select. Yeah. So do a select, and then here, I want you to do that candidate mask and mask not equal 0.
I'm not sure what I'm.
Candidate mask and mask not equal 0. So select the so C.
Oh, okay.
Yeah. So this is going to slow
Expression
things
range.
down because we're going to do it for all of them, but it will be okay. I mean, it's not great, but it's okay.
So we're selecting this value and returning
Select
C2.
needs to have a lambda. No, you want that debug. Oh, no, you don't. You're right.
We're changing what this is now.
Yeah, so where it says candidate masks and masks, you have to say C goes to C and mask equals 0.
So we don't.
Good. Okay, so get rid of that and let's commit this. So we've made things worse. Step 1.
What do you want to call this? Use select.
Yeah. So now what I want to do is I want to change this select to, we have a like get possibilities for mask. Actually, hold on. I want to do something else first. Go back to that select.
Right.
So where you have C, I want to pass in C and I.
Okay.
So the thing that we're trying to solve for is we want to turn this into a link statement where it's giving us a selection of numbers rather than masks. So now I want to say so in that select, if the I is, you can do this as a ternary, but if I is not equal to index.location, or location.toIndex, then return null. Otherwise, do this thing. So now we're only calculating it for the thing. I don't think this should affect anything, but let's find out.
So we're now mixing null and
Yeah, so put
bool.
0 or -1, or I'm not sure what or booleans. Good, there we are. Thanks.
Okay.
Wait, did that fail?
I don't think it should fail. No, it failed.
So change it to do the same thing whether it's true or false.
Oh, you mean that.
100% don't understand what just happened.
Something happening in 2 index? No, that's not a big deal.
No, go back. Do this. Revert, revert, I guess. If reverting is the wrong thing, we didn't commit fast enough. Okay, so here where we have a C, make it C and I. So the select,
no.
take a C and I. Don't do anything else different. I just want to see, is there something weird about the fact that we use this method instead?
You want to commit that?
If it passes, I want you to commit it. Okay, it did pass. It seems like it was slower than it was before. Okay, and now let's do the if I equals location.toIndex. Do this, otherwise do this. There's no way that can fail. I think we're at the same place that we were at before. So I equals location.toIndex. Then do this, otherwise do that again. Yeah, it does. We're still using the element at. The real question, Claire, is how does this fail? Jay, how does this fail?
So if I do this, I don't know. What if we have an idea?
You can just do there to change that to false, and this will pass, right?
If we print this,
sure,
that should have no effect, right?
It fails though. So comment it out.
I don't know if it's done failing,
but it is failing. So okay. comment out line 269. Wait, what? Okay, and now it's passing.
Mm-hmm. Okay, is it the I or the location 2 index? So we're going to...
Great point. Console write I.
I'm ready to do that one next.
Okay. Ah! My brain is broken right now. What is happening?
Okay, location. Does locations 2 string do something weird?
Print row and column. This is a read-only data class. Try this. Go back.
I'm trying so hard to go back.
Just do an undo for a second till we get to basically where we were before. More.
Here you
more. Keep going. Keep going. More. Can you go back even farther? Okay, so here on the return on 269, put it back in. Do the I is equal to location.toIndex. Writing to console will make any approval test fail? That shouldn't be the case.
But not hanging.
So hold on. So now extract location to index to a variable outside of this. Sure. What? Why is it red on location index? Sorry, you need a question mark after it. Oh, no, you're right. You can just do an and. That was nice. The and is more elegant. This is breaking. Oh, no, this is passing. Okay, I fundamentally don't understand what's going on, but I'm happy that it's working. So now let's do the and instead of this. This, because that's better. Oh, Claire makes the point that we are capturing output from the console. So writing to the console would make things break.
It's true.
Yep.
But that would cause a difference.
Of
that
approval,
fails.
not a timeout, but
Yeah.
maybe it's just a lot of writing. But okay, but if we go back to where we were, this is now. Wait, are we red right now?
Timeout.
What? It's a timeout? How can that be a timeout?
I don't know how computers work.
Yeah, revert. Okay. What? Okay, just extract location.to index. Did did that fail?
That looks faily to me. Timing it. Why would calculating location 2 index earlier make a difference?
Undo that and it passes.
We have a 10-second timeout. It's too long. Okay, that passed. I wonder if we're slow, like we're near the 10-second threshold. And so when we make it slightly slower,
But we are near a 10-second. But calculating it early can't. I mean, we'd have to be so close to the 10-second threshold that this would make a difference on that. Oh man, so this piece of code is very, very confusing for me. Would you agree with that?
So it took, when it succeeded, it was 9.7 seconds. So if we do anything to slow it down, we cross the threshold and start timing out.
Okay, so let's try this. What I'm about to do is a little bit weird, but we're just going to try it for a moment and then we're going to give up. So on line 262, where it says candidates, yeah, in here, I want you to do a new line and say, no, inside of here.
You see the dots are black, right?
Yeah. That's a really good point. Remove that and go find candidates. Because we were making a call that we inlined, and then it turned out they get candidates here. But on line 100, where it says candidates, New line.
We're at our
Select
little mini time box.
candidate values. No, it doesn't exist yet. Equals candidates dot select dot masks dot select dot, and here you're going to say m goes to m dot, or there's a method. It's like it's not going to be m. It's going to be like get get digits for mask. Yeah, and past that m. There we go. So now we're calculating this once.
Is this a field?
Yeah. There's a slight chance that we're modifying the other thing, which is what's disturbing me. But let's try and see if this works. So here, this entire thing we're just going to rewrite for a moment as candidates to or candidate values dot element at location dot to index, and then dot contains digit, and return this. Does this work? Nope.
Oh, we hit the threshold. So I think we.
Oh yeah. Wait. What?
There you go. Now it
There
passes.
we go. Good. Clean that up and. Okay, so let's start by understanding this just a little bit better, right? Which, to my mind, would mean the way that this is working, or the reason this stopped working when we did it, is because we're just right on the edge of how long this takes, right? So we got a lot of false failures where the code actually did work. It just took longer than it used to. And therefore, it was going over a threshold because we were right on the threshold.
Mm-hmm.
And that generated a lot of confusion.
So the time is right about 5 seconds now. So it looks to me like there's something we were doing twice, and now we made it do it only once.
Yeah, well, now because we're calculating this. Before we were calculating it every time we asked, is the digit possible? Right, which
and
is
then
the whole
Claire
reason
asks, how long did it take before? And maybe it was 2 to 1. Maybe that was when we made it slower.
Yeah.
Okay.
So now we're back to a much better situation. Let's commit this and then let's switch our gears.
Okay. All right, it's all committed. You want me to push?
Yeah. So we are going to have to take a break for a while, and that means we're going to have to stop doing these refactorings. And we've been doing this now for quite a long time.
Just to be clear to the audience, a while includes upcoming weeks, not just like the next hour.
yeah. Like so probably all of September, and possibly the fall. We're going to have to take a break. But we started somewhere and we ended somewhere, and we haven't really compared or looked back upon those two things. And we thought it might be a good idea to do that now. Am I in the right neighborhood here, Jay?
Yeah. I like that. We haven't looked at the whole thing, and I don't know how to get like a broad view of it, but one place to start might be look at the original code and marvel at how
let's
much
look at the metrics of what we got now. Okay. Right? If I was going to show something to, people with suits, I would need some sort of metrics, and we have a metrics, right? It's under Analyze, I believe, in Visual Studio. Up at the top. And we got Run Code Analysis. Calculate Code Metrics, actually 3 down. For the solution. What does that tell us? All right. So we have I pretty much we're carrying here about the Sudoku kata, not the tests.
Yeah.
So we have a maintainability index of 78. Is that good or bad?
I'm deciding it's good because it's where we are. I don't know.
I'm deciding it's good.
I kind of want to compare to before all of our changes.
I do too. So you want to like export this or screenshot? Probably there's a way of exporting this, right?
I bet that's a thing they can do. Let's see. Apply. No. Add, remove.
There's an X there, isn't that Excel?
Open
List.
list.
Is probably
But
complaining because we don't have Excel.
That's a good guess. I've got a screenshot.
Okay, you got a screenshot. Did you take the screenshot on this computer though?
I'll bring it over to this computer.
Just take it with snippet.
I'm halfway through. Otherwise, I would switch.
All right, fair enough. Okay, so then let's switch our branch to master.
It's going to be ugly.
And let's run. Yeah, let's run this here. Maintainability index 11. So let's look at these two things side by side. You need to make your image bigger.
Or maybe too much bigger.
So if the what? Oh, okay. Open up program though. Although program doesn't really have anything in it, does it?
Well, so here's some things we can notice. Just shy of 1,000 lines of source code and 500 lines of executable. Here we're almost 1,400 lines of source code and 500 lines of executable. So executable code barely changed. Source code increased. That's because we added some constructs and classes and the like.
Classes, method names, methods. Yeah. Lots of methods, really. Apparently, 400 lines of methods.
Class coupling, well, that makes sense. We have classes now. That wasn't true before.
Yeah.
Depth of inheritance is the same. Cyclomatic complexity, we're up.
Which is weird.
That's interesting.
But we're up overall, it says. Right? So like if it was to flatten everything. But if you look at the individual things, it looks like we're down. Although not much. It looks like the Sudoku kata still has a cyclometric complexity of 94. Can you open that Sudoku kata up?
Where?
Oh, no, in the new one. Right. So we took the screenshot slightly the wrong way because this doesn't have depth to open up and the other one does.
Okay. You want me to do it again?
Yeah.
Snipping tool. Is this what I should use? That's that one. And now we gotta switch.
Maintainability index 0. That does not seem good. It's also weird because it gives there's something weird about the way it's averaging those two numbers, right? Because overall, this project has a maintainability index of 11. The main, which only has 8 lines of source code, is very maintainable. And where all the source code is a 0. And somehow those two things are averaging out to 11, which seems deceptive. It's like the thing you never look at is really maintainable. And the thing you always have to maintain is completely not maintainable. Those things don't average.
I'm amused by the fact that my inability to switch branches is showing up as an exception, not as an error message, because I guess that was a surprise to the authors. Sorry, authors of the Git window in Visual Studio, but you messed up here.
Yes. Also not sorry.
I've shipped plenty of exceptions. We're in good company.
No, yeah, we're definitely in good company. But also, it needs to work. Okay, so now if we open this up,
What do you want to look at?
well, Sudoku kata, because that has such a huge complexity, which I didn't think it would. If we scroll down here, what's the highest complexity we got?
It's added. So
Oh, weird.
this is a part of cyclomatic complexity I think we don't talk about very much, because usually we say for a given like sequence of statements,
Yeah.
how many loops and branches and stuff are in there. And having multiple functions is a different kind of cognitive burden. I have to understand how the functions relate to each other. But I think because academically we're so focused on individual procedures that we miss that relationship. And so this view is summing those all together. I assume it's summing to get a cyclomatic complexity for the aggregate. And it's appropriate. Like, so there's a Kent Beck talks about a power law curve, power law distribution of
Yeah.
cyclomatic complexity, that usually a handful of functions have a ton of complexity and all the rest are really low. And that was definitely true of our original.
Yeah.
We've got 1 and 113. And now it's
Oh,
more
that one was
even.
much easier to see that it adds.
Oh yeah,
Because 113 plus 1 is 114.
do that math. Whereas here, like, okay, so I'm curious to see the histogram, but it only goes up to 19 at the peak.
Yeah.
So even if the distribution is still power law, um,
Can we take
I
a look
think
at
it
that
is.
19?
Yeah.
Because this is now the most psychomatically complex part of our code. Oh,
And it's
sorry.
this function.
That's deceptive as well.
Well, the class has this total complexity.
Yeah. So
And
let's look at the 10.
sorry, did I click the right one?
Yeah. Because now that's the
This
highest
one is
number. It looks like
7.
7 might be the highest number, but open up that 10 because that might be a class 2. It
Yeah.
is. So 7 is our most cyclomatically complex,
Yeah.
which is what?
And here
The
it
thing we're
is.
looking at right now?
It's a
So,
loop containing a loop containing an if.
yeah. Which, fair enough. Like, there is a fair amount of complexity there. But to think that this is the worst code in the project right now.
Mm-hmm.
Yeah. There's a cognitive complexity, which is a thing that would be interesting to see right now. It also means like our worst code has a maintainability index of 62. I still don't know what this number means, but it seems good. Better than 0.
This is the only function with cyclomatic complexity above 7.
Yeah.
So from that particular perspective, I think cyclomatic complexity is a useful metric as far as the measures go. I'm okay with it. But this function, which fits entirely on the screen, is our worst.
Yeah.
I'm okay with it.
So let's go take a look now at the code of where what's in Sudokuorg.board is a question from Claire. Let's go take a look at that. Sudokuorg.board.
This one.
Yeah.
Go
Open that up.
code. Okay. Sudoku board is this weird thing.
Underscore board.
I think she's asking about this class. Oh, Sudoku kata.board is the namespace, which contains a class Sudoku board.
Right.
Our namespaces might not be the best.
They might not be. This is also an interesting thing, right? Because now we still have this candidates. We have the candidates values. I feel like our goal now is to remove candidates and only have candidates values. But that's not a thing we're going to do right now. Right.
So it's used there, there.
If we
Wait a
could
second.
move to candidates values being the things that's used instead of candidates,
Yeah.
then we make it so that we no longer have masks.
Neat. That'd be good.
Yeah, that'd be
I'll
very
have
good.
to do.
Let's add into that to do keep candidate values or move to candidate values.
Migrate. Makes it sound all businessy.
Migrate. Ooh, that sounds fancy. All right, so let's go take a look at that original code because we just looked at the worst code here. Let's look at the worst code there.
Okay.
So the best way I think to do this, oh yeah, you can just switch to master.
I've also got it open in the browser if you just want to read.
Let's go to the browser and where it says github.com, can you make it github.dev? I believe it will have a whole side view. There we go, way on the corner. So this is the worst code that we started with. Scroll down so we can see the whole thing. There we go. And I'm sort of again just looking at the right hand corner here. Yep.
I don't know what I'm seeing, but the first thing that I notice in this is something about the shape. It catches my attention.
That shape in particular?
Yeah,
Which
I don't know
Loki
why.
did for starters. Right?
There is a kind of straightness to it. We've talked about this in Sparrow decks, like
Yeah.
that pre-cognitive matching or whatever. And for some reason, my brain went there.
Yeah.
I don't know what it is.
There's like some weird repetition occurring here, but it's different. It's like, yeah, there's a block here, there's a block there. Keep going down. Keep going down. We're only halfway through so far. So this is the worst code of where we started from.
I'm really impressed that a person was able to write all of this as one long function.
Yes.
Somebody's like cognitive ability to be able to
Far
manage
exceeds
1,000 lines of code in one function and make it work. I don't know what techniques they use to manage all of that.
Yeah.
It's pretty amazing that a person can do that.
I 100% agree with that. One of the reasons I think I am actually really good at writing code is because I'm really bad at handling this. Right? Like, I can't cope with methods that are over 20 lines. And as a consequence, I don't write methods that are over 20 lines. Right? So, like, if I was better, if I could handle stuff like this, maybe I would write more stuff like this.
Mm-hmm.
But I can't. It just does not work for me. So, like, as a coping mechanism, I had to learn how to break things up. Let's go take a look. So this architecture though is much simpler, right? If we were to like UML diagram this, it's very simple. You call this and it returns a void. Right. Let's go take a look at our architecture.
How would we do that?
What? Yeah. So is there like a way, a UML extension to here? You know Visual Studio better than I do.
Code analysis is FX cop. It's not really what we want.
Yeah.
Is there a built-in code cleanup? Okay, I didn't know that. I want to look at that sometime.
Visual Studio UML diagrammer generator.
Class diagrams, right? There's a class view. I don't want to install anything. We ain't got time for that.
All right. Well, let's go look at our side thing then.
Class view. That doesn't. The view here is not a picture. It's just
Yeah.
the classes.
But still, I think it'd be worth sort of diagramming out the solution, even if we did it by hand. What do you
I just want to
think?
mention some people use class view instead of solution explorer. In our code, they tend to match. We tend to keep them in alignment. Some people work that way.
No.
All right, what did you want me to do?
Let's open a like a draw IO or something. Can we do that? And is there like an anonymous way of doing this? Decide later. There we go. Okay. So yeah, let's do some rectangles. So what do we got? Like go back to our thing. We had the Sudoku. We had the same starting point that they had. So this starts with Sudokuorg.play or something. No, go to our test. We'll find it there. Or the main will tell us too.
Oh yeah, main is main. Main calls play.
All right, so let's go to play. Okay, so we have program.play. Let's put that out. There's actually a class thingy. Do you see what I'm talking about? This thing. Vertical containers. So here we can do like a program and a play inside.
And what goes inside here?
It's just play? Text. Yeah, play. So before, like this was the entire UML diagram. So let's go see what our play actually does here. So our play calls play again, but so we'll just ignore that for right now. And then this goes to Sudokuorg generator. So let's make that class and call out to it. And then it has a generate board or something.
So I don't know what you want here, an arrow?
Well, let's start by making the method, and we'll call out to the method.
Okay. So it calls
construct fully solve board. And then play should point to that. Yeah, sort of.
I'm really good at this. I don't know what you're talking about.
Okay, so then let's see what else happens. So then on salt there's that, so we're going to go that.
So that's on the
It's on the board. So let's put it. Oh, so this returns a board.
Yeah.
So yeah, let's make another class that has a board.
I have the type in my clipboard. Here we go.
And this is construct fully. Or no, this is generate puzzle from completely solved board.
It's not responding. Come on, come back.
You want to put text in the middle of that?
I'm clicking on things and it's not happening.
Page unresponsive.
So I said.
That's not great. Say wait. Is it responsive now?
No.
Oh. Try refreshing the page. Or unsaved changes. Click here to save.
I can't because,
exit page. Let's say exit page. Let's try. There we go. Okay. Yay.
Thanks for not losing my data.
I appreciate that as well. Okay. So this is that method.
Oh, it's freezing again.
It's frozen again. All right, exit page again. Try might not be the right place to do this. What would you suggest as a good thing to use?
I don't like trying.
All right, let's do it.
What? I don't like drawing.
Oh, you
I
don't
don't
like
have a
drawing.
better. Yeah,
Oh, sorry. I misheard what you said. Okay. Do this in like a PowerPoint. We could do it in a. We could do it just in a Jamboard. Let me try something for a sec.
sure.
I don't want to do that right now. Uh, let's try. Sure. What do you got, Lucid chart? Make a diagram. No. Yeah. All right. What else you got? All right. What do we have that doesn't have a login? Huh. Okay. Can we cancel or not do this? Just say continue. Not really. That's super annoying. Okay. Smart draw? Will you let us do it? Try it now. But we don't want to sign up. Wow. Okay. What do we got for, what is it? Is it paint now just?
Paint.
We
Hey,
got
paint doesn't require a login.
There we go. All right. So what did we have? We had program. And program had play.
Yeah.
Is there like a select thing here? There's not. Fun. And then we had the Sudoku board generator. And it had generate fully constructed board.
Yep.
Maybe make that a little bit bigger. And just do that. Or make that a little bit smaller so it fits in the thing. Oh, that's weird. Let's try that. There we go. Okay. And then we also had the Sudoku board itself. And I forgot what it had. Can you remind me?
We can go look at the code. You want me to take over the typing?
Yeah, if you don't mind.
Sure.
Okay, so it had the generate puzzle. Okay, and then if we go back, then we had this solve puzzle. Yeah. Which was part of program. So if we were to draw arrows here, this like calls this, calls that, calls that.
I think the arrows that I'm going to get here are terrible. But
That is terrible.
Really
You're right. Try just lines.
I think we'll take the content.
Yeah. Well, no. So it's actually not the first line. So undo twice. So call to the second thing. Play goes to generated.
Oh, you're right.
And then it goes to generate puzzle from completely solved board. And then it goes to solve. Beautiful. Solve puzzle. And basically, like, that's it. But I feel like solve puzzle needs to be delved into. So let's go look at what solve puzzle does.
Calls get candidates, get Sudoku solver steps, and then it iterates on each of the steps. I feel like I want to talk about what we're noticing. What are the insights that comes from this? I don't know what the insights
what
are.
I'm noticing, if you go back to that drawing, is that like these boxes don't need to be opened. Right? Like I don't have I have a desire to know, like, okay, solve puzzle seems like a box that like might be nice to open. Right? But generate fully constructed board, yeah, I'm good. Like I don't need to open that box to at all. In this generate puzzle from completely solved board, don't need to open that box. Like feels it feels like I'm very happy to have that container. Solve puzzle, like I know what it does, but it makes me curious of like, well, how does it do it? Does that make sense?
Mm-hmm.
You feeling the same way?
Yeah, I like I don't know. There's something else. So we had this question early in our refactoring about whether we could change the rules of the game
Yeah.
in a natural way.
Yeah.
I feel like that's partly true. Like there's some rules that are now accessible and some that aren't. So the main thing that has become flexible is the strategies for solving.
Well, yes. Although also, if you remember going way back, our first goal was to actually make it so it could solve a puzzle that we gave it.
Okay.
Right? Which it can now do very easily. Just call 36.
Yeah.
Right? Hey, solve this puzzle.
Yeah. So we had an idea of like a rule about the knights movement, up 3 over
Yeah.
2 or whatever, up 2 over 1. And whether you could add a constraint like that and make a puzzle.
Yep.
And I don't think we haven't really talked about what it would take to implement that, but I think we're better off now than when this started.
Well, get the Sudoku solver steps would be one. Go to that.
But the other thing that we noticed is we think that these rules have some overlap.
Yeah.
And that if we were willing to take let go of the intermediate states, we could actually simplify the solver.
Yes. Because pick with one cell, pick unique, and pick possibilities for those and do something. By the way, those names could probably be better. 67, I think, does all three of these.
Yeah.
Right? So 67 says, like, hey, if there's only X possibilities, remove them from the other ones.
Yeah.
Yeah.
If you were a new developer on a team and you were responsible for this code and you didn't have anybody else to call on.
Yeah.
I think probably me and probably most developers, when we look at the original code, would say, oh my God, this is terrible. 1,000 lines. I don't know how to manipulate it.
Or even where to start.
Or to start. I'm going to have to be really smart and I'll probably mess things up along the way. The code that I see here, I think people would still have a negative reaction to. But if they didn't realize, they might not realize how good they got it. Like there's plenty of things about this code that feels complicated. As a new developer looking at this, I think I would say, I'm having trouble making sense of this. There's a lot of different moving parts. Why are all these solver steps here? What is a solver step? Why are some of them named and do something? Like, how can I understand what that is? But even though that person might be frustrated, there's a structure here that's helping them. even if they're not aware of that fact.
Yeah.
That there are parts where the previous one didn't have parts, and these parts are reasonable to understand independently, which was not true of the original code. So I feel good about our progress. I don't know how. I don't feel like it would be appreciated by somebody reading it at the current state,
Well,
unless
okay,
they
so
knew what to
there's
compare
like
to.
two parts of what you said of like basically like the first part where you're like, if I was a new developer, would I like choice A or choice B? Um, and I think we're pretty solidly like I would like choice B,
Mhm.
right? But there's two parts of that, and I wanted to break those down before getting more to the philosophical issue of like just the fact that people always want more and never know
Mhm.
how good they have it. But like, there's two things that makes me want to be in this code base more than the code base we started.
Okay.
And one of it, a big one of it, is the tests. This
Yes.
code
Yeah,
base,
that's true.
I feel safe in,
Hmm.
and the other one and we got the test in like day one, right? Like we've been working in, so it didn't take long to get us to a place where we felt safe to change it. And those tests have saved our butts countless times, right? There are many, many times where we refactored incorrectly and the test caught it.
Yeah, that's
But
huge.
so that part is definitely the case. But then the vast majority of our time hasn't been spent writing tests. It's been spent improving the code. And that is something else. That like this code is code that I can work in pieces of that is massively untangled. That has like okay, so you were saying like, what if we want to add the chest constraint, right? I
Hmm.
know we should be looking here.
Hmm.
What if instead of a 3x3 numbers 1 through 9, we wanted 4x4 squares 1 through 16,
Hmm.
right? Like I know where we should be looking for that.
That's going to be hard, right? That assumed rule
Yep.
exists all over the code still, but I think
Um,
we have a better
I
handle.
don't know that it does actually. I rather think it only exists in Sudokuorg.
I mean, it exists right here.
That's a fairly good point. Um, yeah, and you're right. That shouldn't be 80, right? That should be calculated out of the Sudoku board.
Yeah, unless that's a terminal width. I actually don't know whether it's 80 or 80, 81 minus one. Uh, okay, we don't have to
Oh, you're
answer that
right.
right
It
now,
is a
but
terminal width. Oh, that's funny.
it's one of those two things. Um, yeah, what if you wanted to make a Sudoku puzzle that was 3 dimensions or had
So a
a
three by
diagonal
three cube of 27.
yeah, or had like a diagonals constraint, or
Yeah.
used um, like no two values that are adjacent can add up to 10 or something. Like there's all these different kinds of constraints that might be interesting to add, and I don't feel like there's one place where I can plug in a new rule.
Well, no. So there is sort of. Well, there's like two things that you would need to deal with the rule. If we go back to the picture, so the generator, right? Because so if the new rule also needs to generate puzzles that satisfy that rule, right? Then you would need to modify the generator
Mhm.
and the solver. So if the new rule is how we solve it, then we have to just change the solver. If the new rule affects how physically what a board looks like, then we need to affect the board. So if you want to go to a 3D board, you'd have to get the 3D. 3D is going to be the hardest of the things you said. But if we kept it with a 2D, like 4x4, very little would change actually, right? Like the main thing that would change is that the the thing that tells you like the row and the column and the group. Right? Also,
Yeah.
I think there might be an inherent concept of nineness in here somewhere that I don't think we
Yeah.
ever extract out. But
I
but
think
like we have a place where we can start doing stuff with that.
it's true.
Where in the other one, it would just be like in the original code, if someone was like, "Hey, can you make this 4x4 grids?" I'd just pretty much be like, "No." Whereas here, that strikes me as something I could do. Right? So, I mean, this people don't think about this too much, but even if someone's not a jerk like me and just says no, let's say you have a very happy to please programmer, and um and you're like, hey, can you make this a 4x4 constraint? And
Hmm.
they're like, yes. And then like 6 months later, they're not done,
Hmm.
right? Then what happens is you stop asking for those kind of things, right? And I see this especially like in mainframe programming teams, right? Where you're like, well, what would you like to be able to do that you can't do right now? And they're basically like, nothing. We can do all the things we want to do. And then you realize that the reason for that is they've stopped wanting to do things,
Uh-huh.
right? And so where they really get upset is when there's something that like they have to do. So like
Uh-huh.
I'm thinking of a company where Visa and MasterCard changed their rules on
Uh-huh.
what can be stored, and it was really excruciatingly painful for
Uh-huh.
them, right? Because it just went through the system so deeply. And if you ask them ahead of time, like, what would you like to do? Well, be able to change the way we store, identifiable financial information
Hmm.
would not have been something they wanted to do, right?
Yeah.
Because they knew how hard that would be. So in their minds, it's like, well, I don't want this because it's so expensive,
Hmm.
right? Like, oh, I'm not thinking right now of like, oh, I'd like a Lamborghini because I know how expensive that is. It's just not, it just doesn't seem like something. But if Lamborghinis cost $5, like I might buy a couple,
Hmm.
right? So like there is this relationship between what you want and what you can get. And that adjusts. And here, when I look at this code, I find myself wanting more things than when I look at that original code. Does that make sense?
Hmm. Yeah, yeah. I've been thinking recently about a project that I worked on where while I was working on the project, I tried to advocate for good test coverage, clean code, good documentation, because I said eventually somebody else will be working on this, not us. And even though I thought I was advocating for that continuously throughout the whole project, after the project was shipped and another team took over, they were so lost.
Yeah.
And I thought, I thought I tried really hard to make this transition easy, and look how badly it went. And wow, okay, the bar is way higher than I was aiming for.
There's also it's very hard to know how things look to a beginner. Like
Yeah.
it's almost impossible to forget the context.
Hmm.
Have we had this conversation before about the that line from the "You're Not So Smart" podcast?
Probably, but tell me the line again.
So let me. Uh, oh no, let's try again. Nope, it does not seem to like me typing. Oh no, now it does.
Claire says thanks for us running this series. Much appreciated. Uh,
Oh,
you're welcome, Claire. And I also am grateful that Claire has shown up so many times. And
and start us on this experiment.
yeah, yeah, thanks for that. And she has seen things that we couldn't see, and also found, like, I know sometimes it's frustrating, like, oh, I want you guys to see my words and do this thing, and we're like, oh, we don't notice, we're just looking at the code. uh, I, I know that was happening for you, but I really appreciate all of those insights and inputs and suggestions along the way. um, my favorite audience member, I guess.
So, this is just the book. I want the podcast. There's an episode here. It's like 100 and something. Yeah. For some reason, I think it's desirability bias. I could be wrong on this. No, it sort of looks right. Let's see if I'm right. Somewhere around.
Music in this episode, as always, is spelled Take. 2 minutes. That's -, for more mindfulness tips. Episode 103. Mention of detecting something unusual within the sound.
Yeah,
Something
this.
distinct. Within all that noise was a snippet of audio created by Matt Davis, who's a scientist at the MRC Cognition and Brain Sciences Unit at Cambridge University. He researches what's going on in your brain when you try to understand language. Here is
We should stop because we don't want to spoil this for anybody.
Research.
Yeah, so that line right there, I'm guessing is nonsense to you. Is that correct?
I've watched this. I listened to this episode before,
Okay.
and I've been trying to find it for months. So thank you for. I want to share this with other people. I'm going to grab that.
Yeah. So like now that we've heard it, that sentence makes sense to us, and but it's so hard to realize that has occurred. Right. So when you have your code, you're like, oh, this all makes sense in the same way as that sound just made sense. And then all of a sudden, like someone else does it and it's complete nonsense to them. And it's so hard to know that.
Yeah.
There's one other thing I wanted to just talk about, maybe not go into before we leave, but we have been comparing where we ended up with where we started.
Mm-hmm.
And we haven't really looked at the middle space. Does that make sense?
Mm.
Like, it's not like just, hey, today it's good, and in the beginning it was bad.
Mm-hmm.
There was a part where this shifted, and even like I can remember shifting where it's sort of like, if we go back to our commits here. So we go here. So we have branches, which is interesting, like because we've been doing it this way. So we've done 24 branches. That's pretty good.
Nice. It's like almost 1,000 refactorings.
Yeah, it's got to be.
I see that number, the 949.
Yeah.
Maybe they're not all refactorings, but 900 refactorings.
Yeah. And, like there was that first part, mostly what we did is break stuff up.
Mm-hmm.
Right. And then there was a part where we started like cleaning stuff up. And then it felt like we spent a lot of time in the solver. And then it felt like we started moving towards stuff like masks and creating board concepts. Does that make sense?
Mm-hmm.
And so depending on like where you would hand this off, like broken up is so much better than one piece. When the solver started to like get cleaned up, that felt like, okay, I could have come into that code base and gotten to where I needed to be pretty quickly. And maybe it would be a place that you then need to solve or clean up a little bit, or maybe it would be someplace where you didn't, depending on how you needed to modify stuff. At these end parts have been like very small methods that we've been cleaning, right? Where it's like, okay, we're down to like 30 lines, 20 lines, but how can we make it really clean? Like the stuff we did today, Let's see if we take a look at that.
So 900-ish refactorings, and this is our 22nd episode.
Yes.
And we do approximately an hour of refactoring.
A day.
Some setup and some retro, whatever.
So we've done about a half week of work on this.
Well, a real work week, this is a full work week we've done.
Yeah. So you're saying 40 hours of work.
So 20 hours of refactoring, 20 hours of meetings.
Yeah, it's a full work week. I love that. That's beautiful. So what was the method we did today? Do you remember?
I don't remember the name.
Oh, here it is. Is digit possible? So if we look at this method, when it started, it was like 5 or 6 lines of code. Right? Like there's some part where Claire was like, it was better before you started making it worse. Right? And she was right. It absolutely was. Like normally in the refactoring journey, there's this part where it goes through ugly to get to where we want to be. The other thing that's nice about this is this is really, it's a list, I think.
Right. Go ahead.
Or enumerable. But the thing that is nice is this is also very clear, right? Mm-hmm. Go to the thing, get the element at, and check if it contains the digit. Mm-hmm. Where the last one was more masky, there was like a bitwise and we had to get the mask for the digit. Like it's just more complicated.
Yep.
Right? This is really straightforward. And so I feel like this kind of work is like polishing, right? Like in the beginning, it was almost like excavation. Like, let's get this, just separate things apart. We're moving huge chunks of stuff, right? Then there was this like organizational phase. And now it's just like we're putting that like final shine on, right? In my mind, I'm sort of separating these into like 1/3, 1/3, 1/3, but I don't think that's accurate. I don't think that matches the actual data. I'm wondering, can you see that if it was all in commits, it would be very easy to see where it occurred. Is there a way to easily see like where, like patterns of how our work changed?
I don't know. I mean, I kind of want to see like numbers of lines changed in each commit. That might be a hint. I noticed there was a time where we said, "Oh, it feels like this is going faster."
Yeah.
Remember that? Like that?
I do remember that.
There's no way to get a proper scroll bar here.
Can you get so right here, you're only seeing a couple different branches. Can we see all the branches? Let's open remotes.
This is all. Oh, I see what you mean.
Oh, I see what you're saying. You're saying in our current branch, we have the whole history because each branch is branching off the other one. Nice.
Okay, so this is a full scroll bar. Yeah. I don't really know what to notice in here. I guess one thing to notice is
the beginning.
We started in March. 310 was about a screen's worth. Okay.
Yeah.
Did that change? Look at 526.
It seems
it's actually
almost
less than a screen.
Yeah.
Yeah, interesting.
Oh, but I also know why. Go to the very beginning. So notice here, so many lowercase r's. Right? One of the things that jumped out at me was that R bang bang. But so many lowercase r's. And then go up. And more uppercase r's. Now let's go up to like really sort of recent, like maybe 2/3 up. Yeah. Now, there's still a fair amount of lowercase r's, but a lot more uppercase r's.
Yeah. Closer to.
And here, look at that line of uppercase r's there.
Yeah. It's nice to be able to scan this. We've made a visualization for ourselves.
Yeah.
I need to wrap up. I gotta
Yeah,
go
yeah.
deal with the fires.
Well, this has been absolutely fantastic, Jay. I've really enjoyed taking this exercise with you. We'll be back at some point. We're just not sure when right now.
Yep.
All right. Goodbye to everyone. Thanks so much.
Bye all.